find the general solution of the given system. So you are given the system in terms of vector x prime. First is to find a minus lambda I. Let's call this matrix A subtracted with lambda I. That gives you this matrix. Then you are going to find its determinant. That gives you this whole bunch of this thing, this junk. Distribute this out, simplify it, and set it equal to 0. Solve for lambda, you will get lambda equals 1, 1 plus or minus I, distinct in complex eigenvalues. Okay, let's go over each of them. For lambda equals 1, plug it into this matrix. That gives you a new matrix, which is this, augmented with 0. Take an overall look, you see that k1 is 0. Okay, from the second equation, I have k2 equals to k3. So if I choose k3 1, then k2 is 2, then my vector k is 0 to 1. Then that gives me vector x1 is 0 to 1 times e to the t. Now you're going to do the same thing for 1 plus minus lambda plus and minus I. So for lambda equals 1 plus I, plug it into a minus lambda I. That gives you this matrix augmented with 0. Okay, and then if you want, you can reduce it down to base matrix, which is this. Okay, so I'm sure you know how to reduce this down to base matrix, so I'm not gonna go over it in order to save time. Okay, now over here, vector k is equal to, so you have k1 equals negative I x3. You can call it x3 or k3, doesn't matter much. Let's fix it, k3 to match with what we've been doing. Okay, so vector k1 is equal to negative I k3, k2 is k2 is 1 k3, k3 is just k3. Then if you factor out k3, you will left with negative I 1 1. Okay, then your second solution is going to be a real part of vector k, which is 0 1 1 times e to the t times cosine t, minus imaginary part of vector k, which is negative 1 0 0 times e to the t sine t. Okay, so you can multiply this out and simply combine them together, which gives you this one. So how? So you have 0 times, first factor out e to the t because they are in common. Distribute this, so you have 0 times cosine t, which is 0, minus negative 1 times sine t. That gives you positive sine t. Okay, go in the same path, you will get this matrix. Now for vector x3, so from here, from vector x2, you just copy it down to vector x3, but few things you need to keep in mind. Change the sign, so you have negative here. Over here you need to have positive. For this vector and this vector, you just switch the position of them, so bring this to the right and bring this to the left. So for vector x2, you have this multiplied by cosine t. For vector x3, you are going to have this multiplied by sine t. Okay, and this for vector x2 you multiply by sine t. For vector x3 you multiply by cosine t. Okay, that's what I mean by switching it. And then you can combine them together by distribute this in and then add them together, which gives you this matrix. Okay, then your final answer is going to be c1 times vector x1, which is this one, bring this down, plus c2 times vector x2, which is this one, bring this down, plus c3 times vector x3, which is this one, bring this down. Okay, hope that makes sense. That's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.